All right, let's look at a question from the applications of trigonometry related to heights and distances. The angle of elevation of a fighter jet from a point O on the ground is 60 degrees. After a flight of 15 seconds, the angle of elevation changes to 30 degrees. If the jet is flying at a speed of 720 kilometers per hour, find the constant height at which it is flying. I'll draw a rough sketch first in order to represent what is given in the numerical. So let's say this is the ground level, and let us say this is the point O, and this is where the flight is when the first angle of elevation is taken. So let's say this is the angle of elevation, and the first angle is given as 60 degrees. After a while, 15 seconds later, this flight finds itself, let's say here. The second angle of elevation is equal to 30 degrees. Now we need to find the height at which the flight is flying. So let's say this is h, and obviously this also will be h, and this time, not the distance, time is given as 15 seconds of flight. So I'll make a better diagram. This is just to explain how things work, and then we will look at how to solve this question. All right, now look at this diagram. Point D is where the jet plane is when the first angle of elevation is taken, which is 60 degrees. And then 15 seconds later, it finds itself at C. So let's write this angle is 60 degrees and this angle is 30 degrees. So we have to work with this time and this speed. So let me write down, given speed of jet is equal to 720 kilometers per hour. Time of flight t is equal to 15 seconds. Now notice the units of time are in seconds, whereas speed is given in kilometers per hour. So we need to either convert this to meters per second or this to hours. So I'm going to convert this to hours. I'll just divide 15 by 60 times 60. So this would be in hours. This is t. So if I want to find out this particular distance, I would say distance AB is equal to speed times time. So speed is 720 kilometers per hour times 15 over 60 times 60. So 1 0 gets cancelled, and 6 12s are 72, 6 10s are 6 2s are, and then this is 215, that's 30 divided by 10, 3. So we know distance AB is 3, but notice this should be in kilometers because the speed was in kilometers per hour. So I know this distance is 3 kilometers. Let's say this distance is x. Now I'm going to involve equations related to the tangent of these two angles, and we write tan of 60 degrees would be equal to, now if you observe this triangle right here, tan of this angle is the opposite divided by adjacent, or perpendicular by base. So that basically becomes over x. And we know tan 60 is root 3, which is h over x, which gives us our first equation, h is equal to root 3x. Let's call this equation number 1. Then we write tan of 30 degrees. Now if you observe, tan 30 pertains to this large triangle in which the opposite or the perpendicular is h, and the base is this entire distance, which means it is x plus 3. So tan 30 would become h upon x plus 3. We know tan 30 is 1 upon root 3, which is h upon x plus 3, implies h is equal to x plus 3 by root 3. Let's call this equation number 2. If you notice, both equations are in terms of h, so we can equate the right hand sides. So root 3x is equal to x plus 3 over root 3. Now if I send root 3 to this side, it becomes 3x, and I send x here, becomes 2x. So this becomes 2x is equal to 3, implies x is equal to 1.5 kilometers. If you look at the question is asking us to find out the constant height at which it is flying. The constant height here is h. We have a relation between h and x according to equation 1, which is h equals root 3 times x. So h is equal to root 3 times 1.5, which is basically 1.732 times 1.5. If you multiply these two numbers, you're going to get 2.598 kilometers, and that is the height of the jet plane.